TNPSC Combined Statistics Services Exam Unit 1. We had already discussed about correlation and regression. Here we are discussing certain extra points like the relation between regression coefficients and correlation coefficients and how to find the mean of x and y when two regression equations are given. Please note that in the model questions given, in question number 16, there is a small mistake. The answer given is regression of x on y. Please correct it as regression of y on x. The equation given corresponding to that is right, that is y is equal to x beta plus u. Please make sure you correct the mistake. Now moving on, we all know the regression equation is y is equal to x beta plus u. Here beta is the regression coefficient. If the regression equation is y on x, then we denote the regression coefficient as beta yx. And the regression equation is x on y, then we denote it as beta xy. Also we know that the correlation coefficient is r of xy. Now we are discussing the 2 points, that is how to find the mean of x and y when two regression equations are given and how to calculate the correlation coefficient from regression coefficients. The first one, finding mean from regression lines. Here we use a property, and this property is stated as two regression lines of y on x and x on y are known to intersect at a specific point x bar y bar, that is the mean of x and mean of y. So to find the mean of the variables included in the regression lines, we just have to solve the equations. Now to find the correlation coefficient from regression coefficients, we have an equation, and this equation is given by r of xy is equal to plus or minus square root of beta xy into beta yx. The sign of the correlation coefficient is same as the sign of regression coefficients. Now let us see an example. The two regression lines we have found to be 4x minus 5y plus 33 is equal to 0 and 20x minus 9y minus 107 is equal to 0. Find the mean values and coefficient of correlation between x and y. To get the mean values, we must solve the given lines. That is 4x minus 5y is equal to minus 33 and 20x minus 9y is equal to 107. We multiply the first equation with 5 and we get 20x minus 25y is equal to minus 165. We already have the second equation as 20x minus 9y is equal to 107. Subtracting equation 1 and 2, we get minus 16y is equal to minus 272. From that we get that y is equal to 17, which means y bar is equal to 17. And now we have to find the value of x. Using y is equal to 17 and substituting it in the equation 1, we get x is equal to 13, that is x bar is equal to 13. Therefore the mean values are x bar is equal to 13 and y bar is equal to 17. Now let's see the regression line. The regression line of y on xb, 4x minus 5y plus 33 is equal to 0. We have to standardize that is y is equal to, since it is the regression line of y on x, we have to change it to the form y is equal to x beta plus u. When we change it to the standard form, it becomes y is equal to 4 by 5 x plus 33 divided by 5, and that is y is equal to 0.8x plus 6.6, that is beta yx is equal to 0.8. Now let's find the regression line of x on y. When we standardize that, we get x is equal to 9 by 20y plus 107 by 20. That is x is equal to 0.45y plus 5.35. Therefore, beta of xy is equal to 0.45. Now, the correlation of coefficient between x and y as given in the equation is r of xy is equal to plus or minus square root of beta xy into beta yx. That is plus or minus square root of 0.8 into 0.45. That is plus or minus 0.6. Since both beta yx and beta xy are positive, we take the positive sign and the correlation coefficient is 0.6.